In some plants, extraction steam may also be used to supply part of the auxiliary steam demand. For example, in this particular arrangement, steam can be supplied to the air preheater in the FD fan duct from either the first or second stage of extraction, depending upon the pressure available. Please bear in mind that as the load on the turbine generator changes, so does the steam flow through the turbine, with the result that the pressure changes on each extraction point. But referring back to our preheater, how can we heat the incoming air during startup when there is no steam passing through the turbine and consequently no extraction steam available? Well, in this case, a third supply of steam is available from the auxiliary steam system. Each of these control valves automatically opens in the correct sequence. That is, 1, the auxiliary steam supply during startup; 2, the first stage steam extraction during low load; and 3, the second stage steam extraction at high load. So what other sources may be used to supply auxiliary steam? Well, one common method is to use saturated steam from the boiler drum. This feeds through a reducing valve to provide steam at about 200 psi on the auxiliary steam header. Other boilers may also be selected to provide auxiliary steam to the header. The use of saturated steam from the drum is quite adequate, as its temperature of about 500 degrees Fahrenheit will provide sufficient superheat at the lower pressure. From the auxiliary steam header, steam is piped to various applications, such as de-aerator standby steam, oil burner atomizing steam, fuel oil heating. These are just some examples. The actual steam auxiliaries will depend upon the type of installation. Soot-blowing steam for the boiler is usually taken directly from the boiler itself, either from the drum or the first stage of superheat. For the turbine steam auxiliaries, such as the air removal steam ejector and gland sealing steam, a direct supply is usually taken from the main steam line before the stop valve. This high-pressure steam then passes through a reducing station to bring the pressure down to, say, 150 psi. Because of the high temperature of the main steam, a de-superheating station is also included to lower the temperature of the turbine auxiliary steam to about 500 degrees Fahrenheit. Where reducing stations are installed, it is important that one or more safety valves be located downstream to protect the low-pressure pipework in the event that the pressure-reducing valve fails and exposes this piping to the high-pressure steam directly. In some cases, the auxiliary steam piping has to travel considerable distances, for example, to an oil tank farm. There is a tendency for heat to be lost from the pipework, even though it is insulated, and the steam temperature rapidly falls to saturation and condensation begins. For this reason, steam traps are located frequently throughout the auxiliary steam system. The operator should regularly check that the steam traps are functioning correctly, that is, to discharge condensate in regular bursts. If the steam trap is not sealing properly, it will pass steam continuously and so be a source of considerable waste. Conversely, if the trap remains closed, then condensate will accumulate inside the auxiliary steam piping. In this case, we will probably be made aware of the problem by water hammer in the pipework. This occurs as the water flashes into steam intermittently. The water hammer can produce considerable mechanical movement and shock to the steam pipework and may result in broken hangers and supports, as well as leaks at valves and other equipment connections. In operating any of the steam systems, one of the most important operating requirements is to make sure that the system is maintained free of water.